Okay, so we want to find the integral from 0 to 2 of x minus x squared. So using the fundamental theorem of calculus, part 1, which says find the antiderivative, which is x squared over 2 minus x cubed over 3, right? Just using the backwards power rule. And then fundamental theorem of calculus says plug in top minus the bottom. And so then you plug in 2 into these, which is going to give you 2 squared over 2 minus 2 cubed over 3. And then minus, then you plug in 0, but that's just going to equal 0 in this case. And so here you have 2 minus 8 thirds, and 2, well, that's 6 thirds, so that's going to be negative 2 thirds. Okay, so to find this integral, this one is actually a little trickier than it seems, because if you try to use the power rule here, you might be thinking, oh, well, let me just bring it up as x to the negative 1 dx. But notice that you can't actually use the backwards power rule because it doesn't work for the exponent negative 1 because it's undefined. So, but then you remember, you go, oh, wait a second. This dx over x, this is the same as 1 over x dx. And so the antiderivative of 1 over x, well, that's just the natural log of the absolute value of x. And so then you're just going to evaluate from negative 3 to negative 1. Okay, so then you have natural log of absolute value of negative 1 minus natural log absolute value of negative 3. And so natural log of, this is just natural log of positive 1, which is 0, minus natural log of, well, that's just going to be positive 3. So we have negative natural log of 3. Okay, so when we're trying to find the integral of roots, basically what we want to do is we convert it into a exponent. So this is going to be t to the 1/2 dt, kind of like when we were getting derivatives. And then you just use the backwards power rule, just like normal. So we're going to have t to the 1/2 plus 1 is 3/2. And then remember, instead of dividing by 3/2, we're going to multiply by the reciprocal, which is 2/3. And then this we're going to evaluate from 0 to 3. So then this is equal to 2/3 times 3 to the 3/2 minus 0. And so, you can simplify this a little bit, I guess. This is the same thing as 2/3 and then the square root of 3 cubed, which is 27. You can take out a 3 from in here if you want to, right? So if you take out a 3, you would have 3 times 2/3 square root of 3. And so that gets rid of those. So then this is just 2 square root of 3. Okay, so for this function, we want to find first the antiderivative. And so the function, then when we get the derivative of it, gives us cosine of 2x. Well, that's going to be sine of 2x. But then remember, we're going to have to divide by 2 here. Because when you get the derivative of this one, you would have to use the chain rule. So you got to be careful with that one. And remember, when you find the antiderivative, you can always test to make sure you got the right answer. Okay, so we're going to go from 3 pi over 4 to 7 pi over 6. Okay, so then we plug in top minus bottom. So what we're going to do is we're going to have sine of 2 times 7 pi over 6 all over 2 minus sine of 2 times 3 pi over 4 all over 2. Okay, now here the 2 and the 6 reduce to 1 and 3. So this is really sine of 7 pi over 3, which from your unit circle is going to be root 3 over 2. And this is still all over 2. And then minus, okay, so let's reduce this one. This is 4 and 2 reduced to 1 and 2. So this is sine of 3 pi over 2, which is equal to negative 1. So this is going to be negative and negative 1. That's going to be plus 1. And then over the 2 that's right here. Okay, so then this is just root 3 over 4 plus 1/2. Or if you want to, you can write it as root 3 plus 2 all over 4. Whichever way you like. Both are acceptable. Okay, now this one looks pretty interesting because we notice we don't have a product rule for antiderivatives. So this presents a unique challenge at this point. So you can't just get the antiderivative of each one because you're not guaranteed that, very, very unlikely that the derivative of whatever you get is actually going to equal to this. So what you want to do is just think, okay, well, what's the function that when you get the derivative of it, it equals to secant theta tangent theta. So you think, you have your library of derivatives in your brain, and you go, oh, I know, secant. Because the derivative of secant is secant tangent. And so that's it. That's all you have to do. And then, of course, just plug it in. So what we have is secant of pi over 4 minus secant of 0. And so secant of pi over 4, well, this is just 1 over cosine. So this is going to be, so since cosine of pi over 4 is root 2 over 2, this is going to be 2 over square root of 2, which also reduces to just square root of 2. So I'm just going to write square root of 2. And then minus secant of 0, that's equal to just 1 because cosine of 0 is 1. And so that's how easy it was. That's it. Okay, now this one is quite tricky, Anytime you have the absolute value and you're finding the integral, it's a unique challenge. Let me draw a little picture for you so that you can get an idea of what's happening here. We're going from 0 to 7 pi over 6. That's a little bit over where pi is. So let me just draw one cycle of cosine. So this is 2 pi, and here's pi. And so 7 pi over 6, that's a little bit over pi. Okay, now notice that basically what the absolute value does is you're going to find the area, but you have to count all of it as positive. But notice that the area down here, this is going to be, if you use the fundamental theorem of calculus directly, all this area is going to be counted as negative area. So that's a problem. So what you basically have to do is you have to break this up, use the property of integrals that says you can break it up. And so you need to find what this point is so that you can split it up right there. So this is going to be equal to the integral from 0 to this mystery point of cosine And then this part right here, instead of adding it, what you're going to do is you're going to subtract it, because it's going to come out negative. Then you're going to subtract it so that you can make it positive. So, you know, that's going to be the integral from this mystery point all the way to 7 pi over 6 of cosine of x dx. So basically you have this one is already positive, so you're going to leave it alone. And this one is going to be negative, so you're going to multiply by the negative to turn it into positive, because you're finding the absolute value, the integral of the absolute value. So now to find this point, well, that point is basically where cosine is equal to 0, or in other words, when x is equal to pi over 2. And so then that's where you split it up, and that's what this limit is, and then this limit of integration is right there. Okay, so now that we have that, now we can just find this. So the antiderivative of cosine is, let me continue over here better. This is going to equal to sine of x, because that's the antiderivative of cosine, evaluated from 0 to pi over 2, and then minus, again, sine of x, evaluated from pi over 2 to 7 pi over 6. Okay, so then we just plug it in. So we have sine of pi over 2 minus sine of 0. The main thing now is to be careful with your signs, because you have this negative sign here that could mess things up. So I'm just going to put everything in a parentheses here. And then plug in 7 pi over 6. So sine of 7 pi over 6 minus sine of pi over 2. Okay, so sine of pi over 2 is 1, minus sine of 0 is 0. And then we have minus sine of 7 pi over 6. That's going to be, let me erase this a little bit. Okay, so sine of 7 pi over 6, according to my unit circle, is going to be negative 1/2. Sine of pi over 2 is positive 1, but I have this negative sign here. And so when I put these two together, this is equal to negative 3/2 inside, and then times that negative, that's going to be plus 3/2. And so when I add that to 1, then I have a total of 5/2 is the area underneath the curve, if you're counting everything as positive. And that's it.